All right, so we're back on package 6. This is number 13. So to give C of x, it gives a cost in dollars of producing x items of a certain product. Which of the following statements are true about dc over dx, the derivative of C of x? Okay, so let's look at number 1. Well, if the derivative it represents the change in C with respects to x, well, that means the units would be the units of C divided by the units of x, right? Or in this case, we have C would be dollars, and x is like items, so it should be dollars per items. So good. So number 1 is true. Excuse me. And then number 2, the derivative represents the additional cost of producing one additional item. It does, right? Since the derivative is the change in the cost per item produced, number 2 is also true. Any value of x is the cost of producing one additional item. So this one is also true as well. And number 3, dc dx is a rate at which the items are produced. The rate sounds like it should be over dt, not dx, right? We've already established that dc over dx is the change in producing, the change in cost with respects to the items, not the time. So we can't use rate in this case, so this one's going to be false. So therefore answer is 1 and 2, which is choice D. Okay. Okay, continue on to number 16. What is the area of the largest rectangle with lower base on the x-axis and upper vertices on the curve y equals 12 minus x squared? Okay, so let me do a quick sketch of the curve. You have intercept at 12 and it curves downward. This is my parabola, something like this. And largest rectangle, the lower base is on the x-axis. The upper vertices, right, are on the curve. So an example of that would be something like this. Okay, and just to make it a little bit easier, I'm going to call this length here x, and therefore this length here is also x. And this height, if you will, if my value here is x and it's on this curve, then this height would be 12 minus x squared. That's a relationship between x and y on that curve, right? And so if I'm going to find it, the area, okay, let me change that to blue. The area of this rectangle will simply be base times height, which is going to be, I have 2x as my base, and my height would just be 12 minus x squared. Okay, and I'm going to combine those two. So area is going to be, we have 24x minus 2x cubed. And if I'm trying to, what am I doing? Largest rectangle. So essentially I'm trying to maximize this guy, right? So I need to take the derivative. So here we go. I have a prime is going to be 24 minus 6x squared. And we could solve for x here. I believe when, not solve for x, but when I set equal to 0 to look for my critical numbers, then the x value here would be what? Plus or minus 2. So therefore, and the maximum is going to occur when x equals to 2. This is where my maximum occurs. If you actually did a first derivative test, you'll have plus, minus, something like that. And then, so since it recurs at x equals 2, and the problem's asking for what is the largest rectangle, so they actually want the area, right? So let's plug in, or let's substitute x equals 2. So my area at 2 would be 24 times 2 minus 2 times 8, so that you're going to get a value of 32, which is choice D. Okay, moving on to number 18. Okay, so let me get some space here. I'm going to move this up just a bit. All right, so f of x equals e to x natural log of x. What is the, then what is f prime of e? Okay, so we're going to take the derivative first, and then you're going to substitute e for your x once you've taken the derivative. So let's first find the derivative. F prime of x this looks like this is going to be a product rule, right? You have a product there, so we're going to use a product rule. And I have my first term copied down, e to the x, times the derivative of the second term. So the derivative of natural log of x would be 1 over x. And then plus, I'm going to copy my second term, which is natural log of x, times the derivative of e to x, which is e to x times derivative of x, which is 1. And I'm going to combine these two a little bit, simplify a little bit to see what's going on. I'm going to put e to x in front here, natural log of x, cool. And then now we have to substitute e for my x in my prime, right? So I get e to the e over e plus e to the e and the natural log of e. Huh, all right. Well, I know natural log of e, this goes to just 1. So I have e to the e over e plus e to the e. Now, if I look for this in my answer, I don't really see it right away. I don't see any of these choices here being e to e over e. But I know these right here, these bases are the same. So I could simplify a little bit further and say that's the same thing as saying e and then e minus 1. You take the difference of your base, right? E minus, and there's a power of 1 here. And then this will be plus just e to e over here on the second one. And then, cool, I can see that now, right? Let me erase this part. That's going to be choice A. Alrighty. All right, so moving on to number 20. Let me move this over. So number 20, the figure above shows a graph of the velocity of the moving object as a function of time. At which of the mark points is the object furthest to the right? Well, if this is my velocity graph, which it is, right? So let me just put that down. This is my velocity graph. Everything above the x-axis means my object is moving towards the right or to up. In this case, we're moving towards the right. Everything below the x-axis, my particle is, or my object is moving towards the left. And so we're trying to find a location where the object is furthest to the right. So if I follow this curve right here, this is all my positive, right? The object is moving towards the right. And then it slows down as it comes down the curve, but it's still moving to the right. Until it reaches C, right there, that's when it like completely stops, my velocity is 0, and then it turns around and it goes towards the left. So therefore, this would be my furthest right point of this object, right? At that point, after that, it starts going to the left until like all the way to E. This is all negative velocity, right? Even though I realize it curves up and it kind of messes with students right here, it's still a negative velocity. You are still going towards the left. It just kind of slows down and starts approaching a stopping point again, but it's still going towards the left. So in this case here, my answer choice would be C, which is, oh, okay, well, it's C, conveniently. Okay. Okay, so we're continuing on for number 21. So I started a little bit, but I guess I could walk you guys through it. So you're given a derivative, you have what looks like initial value stuff, and they want you to find a definite integral. So taking this derivative over here, I rewrote it over here, we're going to integrate both sides. Okay, so integration of a derivative, I get the actual function, and then I'm integrating 3x squared, you get x cubed, and then here's your plus c. And then I'm going to take the initial value points, negative 1, 2. I got that from the problem here. F of negative 1 equals to 2. And substituting in here, we're going to solve for c. So great, c equals to 3. So therefore, f of x equals to x cubed plus 3. So now they want you to integrate this, right? From 0 to 2, f of x. So I'm going to take my f of x, substitute back into here. So here we go. I have integration from 0 to 2 of f of x, which is x cubed plus 3. And this is dx. Excuse me. We can just integrate that. You're going to get x to the 4th over 4 plus 3x from 0 to 2. And if you solve for all this, I believe your answer is going to be 10, which is choice D. Okay, that's it for now. Bye, guys.